Okay, next I'm going to cover from question from 21 to 30. This is question number 21. You have integral of square root of t and cubed root of t to the fifth. For most of this, when you have roots related type question, you want to convert your question into a power-based such that this is integral t to the power of 1 over 2 minus t to the power of 5 over 3. You want to remember that if you don't have anything on the outside, it's a square root, which means there's an invisible 2. If you don't have any exponent, that's t to the power of 1. And anything to the power of 0 will give you 1. But now, the rule will be the inside the power will go to the top and the outside the power goes to the bottom. Therefore, the second one is t to the power 5 over 3. This one is the power of t to the power 1 over 2 and dt. Then you can use the power rule such that your exponent will increase by 1, and you want to have a 1 over whatever the after adding 1 exponent in front. So this becomes 3 over 2 and 2 over 3, and as the reciprocal of your coefficient. And minus, and this is t going to be 8 over 3, because 5 over 3 plus 1 is going to be 8 over 3. Then you have 3 over 8, balance that, plus c, because it's an indefinite integral. Question number 22. You have integral of t to the third plus 4t squared plus 5 dt. Now this is a pretty straightforward question, and this is a t to the 4, 1 over 4, plus 4t to the third, 1 over 3, plus 5t. Making sure don't forget a plus c all the time because it's indefinite. Well, this is actually it. You can just leave like that, except this portion. You can write it in a nicer way to put it 4 over 3. Question 23, we're having t to the power 6 times t to the power 5 minus 4t to the third plus 1 integrate dt. This is also a pretty straightforward question that this is a t to the power of 6, 1 over 6. You have original 6 come from here. Something you want to balance this two together, give you t to the 5 minus 4t to the 4, 1 over 4 plus t plus c. And you can then you can simplify your result. You get a t to the 6 minus t to the 4 plus t plus c. Okay, now 24. Integral x 1 plus 1 over x dx. And that will be integral of x is going to be x squared 1 over 2. Now, integral of 1 over x, that by conclusion, we have to talk about that little theorem that integral 1 over x, that's actually going to give you natural log of x. Then you have a plus c because derivative of natural log of x is equal to 1 over x. Another thing, if you're going to deal with lots of this question or even on the exam, normally my thinking process is, oh, this is going to be x to the power of -1. Then normally the power rule will tell you you want to increase that -1 by 1. Then you get x to the power 0, which is a number. It just doesn't make sense because when you have a number, taking derivative, you get a nothing. So that's why it will make you think that there's a special formula for this is actually natural log of x. For question number 5, you want to integral 1 plus 3 over x dx. I want to rewrite this question. You don't have to do this in the future, but just to clarify, this is integral 1 plus 3 times 1 over x dx. Right? So because 3 times that, you can put on the top. Then integral of x, integral of 1 is x, and plus c. Now integral of 1 over x is natural log of x, and plus c. Now when we go backward, derivative of x is 1, derivative of 3 ln x is 3 times 1 over x, and that is gone. So this is your antiderivative. For 26, we have integral 2 over pi times x dx. Whenever you see a pi, That's a constant value. Therefore, 2 over pi will be the constant value. You don't want to worry. You just want to multiply it back in the end. You really just integrate 1 over x dx. And that will give you 2 over pi. And natural log of x, always don't forget a plus c. It doesn't really matter how would you put this plus c. If you put a parenthesis, you actually factor out a 2 over pi. But if you just add a c, it's the same thing because we're treating this as any kind of constant number. So with or without a parenthesis, it's going to be this equivalent. Number 27. What is the integral of a pi plus 1 over x dx? And that will be, integral of pi is going to be pi x because that's a constant value. And plus natural log of x and plus c. Integral of 1 over x is 1 over x. Now 28. 28 is integral x to the power of, sorry, they're using t to the power of 4 plus 3 and the t squared dt. Then the way to do this, you could just separate all these such that this t to the 4th divided by t squared. That's just really t squared. Plus 3. Now there's nothing in there. It's really just 1 over t squared, which is t to the negative 2 dt. Then what you're getting here, that will be t to the 3rd, 1 over 3, but balance it, plus 3. T increase negative 2 give you negative 1, 1 over negative 1. Therefore, simplify that, it will be 1 over 3 t to the 3rd minus 3 t to the negative 1, or 1 over 3 t to the 3rd minus 3 over t. Then question number 29. You get integral t plus 1 divided by square root of t dt. Now this looks like a little complicated, but you can do the similar thing with this. 1 divided by another, you split it such that it's a t divided by square root of t. Let's actually have another square root of t left, plus 1 over square root of t dt. You always want to convert this into some power, t to some power. This is a t to the 1/2. And another one is, the bottom one will be t to the 1/2. And because it's 1 over, this is t to the negative 1/2 and dt and integral. Then you can do the power rule such that this is t 3 over 2 divided by 2 over 3 plus t positive 1/2 multiplied by 2, because positive 1/2 when you decrease by 1 is going to give you negative 1/2, and also t to the negative 1/2 increased by 1 is going to be that, plus c. Last question, number 30 for this section, and you're getting integral and square root of t and t plus 1 dt. Now remember, if you have this similar question but taking derivative, this is going to involve with product rule because you have one thing multiply another and both of them have t involved. But now you're doing with the integral. Is actually the product rule, the corresponding product rule in the antiderivative is integrate by parts. That's a little more advanced topic. We're not going to talk about it here. But for this question, you want to multiply in so that this is a t to the 1/2 and t plus 1 dt. Then this will be t to the power 3 over 2 plus t to the 1/2 dt. So all I did is just rewrite my question into some power way. Then the next one is you can integrate it such that this will be t 5 over 2 because originally have 3 over 2. Now I have 5 over 2 and I may have a 2 over 5, balance it, plus t to the power 3 over 2 because originally have 1/2. Now I have 3 over 2, making sure I have 2 over 3, balance it, and a plus c. And that's this 10 question. All right, the next one will be the last practice question. I'm going to talk about it from 31 to 38.